So today we will see how to find the equivalent resistance between the points, between any two given points. So before going to this sum, let us first understand how to know among these resistors which are connected in series and which are in parallel. So let us have a few concepts on the system of resistors connected in series. So let these two resistances R1 and R2 are connected in series. So let us draw battery. Now what we see over here, the current through the battery the current coming through the battery, the same current is passing through both the resistors, and it is coming up to here and it is again going back to the battery. So one thing we have to note that in series, same current will pass through both the resistances. So what will be the equivalent resistance? It will be R1 plus R2. Now a case of system of resistors connected in parallel. Let R1 and R2 be two resistors. Now see, they are connected to a battery. Now see here, the current coming through the battery, it is coming over here and it is divided into two branches, R1 and R2, and again it is getting combined. These two currents are, this current is coming from here, this current is coming from here, they are getting combined at this point, and the resultant current is passing through the battery again. So between where the point at which the current divides and the point at which again the current meets, in between the both resistance or the any resistance that are present will be in parallel. So what will be the equivalent resistance? It will be the product of both resistance divided by sum of both resistance. Now let us solve a simple sum. So let us solve it. So this point is A, this point is B, and we have to find the equivalent resistance between A and B. Let all the resistances are of value 1 ohm. Now see, we have to imagine that battery is present here in our mind. So the current through A will go here. It will divide into two branches, one here and one here, and this same current is passing through these both resistors and it is coming up to here, and again they are meeting at this point. So at this point the current is being divided, and at this point the current is getting combined. So, and here we see that through these two resistors same current is flowing. So these two resistances will be in series. So what we see, so these two will be in series. So what will be the equivalent resistance? 1 plus 1, 2 ohms. So it will be 2 ohms. Then we join like this. So this is A, this is B. So this is 1 ohm, this is 1 ohm, and 1 ohm and 1 ohm will be in series. Now see, this current is dividing here, and they are getting combined at this point and then going to the B. So between these 2 points, these two resistances will be in parallel. So what will be their equivalent resistance? 2 into 1 divided by 2 plus 1. So it will be 2 by 3 ohms. So let us see. We further reduce the figure. So what we get? We get A, we get the resistance 1, and between these 2 points what we get? 2 by 3 ohm. So it will be 2 by 3 ohms it will be 1 ohm, and this is the point B. Now the same current will flow through this branch. So what will be the equivalent resistance? Net equivalent resistance between A and B will be 1 plus 2 by 3. So what we get? 5 by 3 ohms. Now let us solve this sum. So to solve this sum, let us distribute the current. So this current is going through this. It is getting divided into this, this, and this branch. Now 5 ohm and 3 ohm same current is flowing. Then these two current will combine, it will come up to here. This current will combine with this, it will come up to here, and then they will again divided into this and this, and they will then come over here, combine, and the net current will go up to A. Now what we see, 5 ohm and through 5 ohm and 15 ohm same current is flowing. Through 8 ohm and 10 ohm same current is flowing. So this will be in series. So what will be the equivalent resistance? In series 15 plus 5. So this will get reduced to 20 ohm. This 8 plus 10, they are at same current is flowing. So it will be getting reduced to 10 plus 8, 18 ohms. So now how our figure will look like? We reduce it. So when we reduce it, what we get? Through B, this we have reduced. So one branch is for 48 ohms, one branch is for 48 ohms, one branch is for 20 ohms, one branch is for 20 ohms, and another branch we have reduced 5 plus 15, 20 ohms. So I draw the resistor which we have reduced in series combination, and here what we get, again we get a resistance. It was 20 ohm, so we write 20. From here 48 ohm, so we draw 48. In between 48 and 20 we have 6 ohm, so we draw 6 ohm. Now through point A we have 14 ohms, we have 14 ohms. From this point again we have two branches, so one for series combination 8 plus 10, 18 ohms, so we reduce it as 18 ohm. From here again we have a branch 9 ohm, and these two are getting combined, these two are getting joined at 6 ohm. Now we will again do the current distribution. So from this point current is being divided into this and this and this. Now here these two currents are getting divided and they are getting combined at this point. So between this point and this point, these two resistances will be in parallel. So what will be their equivalent resistance? It will be 20 into 20 divided by 20 plus 20. So what we get? We get 20 into 20 divided by 40. So we get 10 ohms. Also kindly note, when both the resistances are same, so what will be the equivalent resistance? It will be R by 2. 20, 20 both are same, so directly the equivalent resistances, if they are connected in parallel, we can directly write as R by 2. So 20 by 2 will be 10 ohms. Similarly 18 and 9 are in parallel, because from here from here when we distribute the current, this current will be getting divided into two branches. We have seen here the current was getting divided into two branches. So 18 and 9 will also, they are combined, they are getting combined at here. So 18 and 9 will also be in parallel. So what will be the equivalent resistance? 18 into 9 divided by 18 plus 9. So what we get? 18 into 9 divided by 27. So we get 9 3 27, 3 6 18. So what we get here? 6 ohms. So we get here 6 ohms. Now we further reduce the figure. So what we get? What we get? So this was point A. So we draw point A. We draw point B. Through point B we have reduced it. So we this becomes a single branch. So now from B there will be two branches only. So from B we draw two branches. From B we draw two branches. So one branch was the parallel combination for this. These are being reduced. So what we get? 20 20 20 parallel, we get 10 ohms. So we draw in one branch we draw 10 ohms. In the other branch it is 48 ohms. So in the other branch we get 48 ohms, and in between 48, in between this point and this point, what we get? 6 ohm. So we draw 6 ohm. Now these two were in parallel. So from A what we will get? We will get a 14 ohm resistance. We will get a 14 ohm resistance, and these two were in parallel. We got 6 ohms. So through a 6 ohm resistance it will meet to this point. So it will get joined to this point. Now again we do the current distribution. So current from here will pass through these two branches. Now look, the same current is passing through 10 and 6, and it is joining up here with the 48 ohms. So 10 and 6 will be in series. So what will be the net resistance? It will be 16 ohms. So we again further reduce, and now see this, the current will come here and the same current flows up to this. So what will be, when we further reduce it, what we get? Through point B, now two branches are there, 48 ohms, and here we get another branch which is being reduced for the series combination of 10 ohm and 6 ohm. So what we get? 10 plus 6, 16 ohms, and then these are joined and they are going to A. So we have here a 14 ohm resistance, then we have a 6 ohm resistance. It is joining up here. Now we again do the current distribution. So what we get? Current over here is getting divided into two parts. It is dividing here, and these two currents are getting combined at this place, and the resultant current is going through this. So when we further reduce it, what we uh, what we see here, the current is being divided these 2 points. So 48 and 16 ohm will be in parallel. So what we get? 48, what will be the equivalent resistance? 48 into 16 divided by 48 plus 16. So what it will be? 48 plus 16, 6 8 14, 4 1 4 5 6 64. So 48 into 16 divided by 64. So 16 into 4 64, 4 into 12 48. So what will be the resultant diagram? So that it will get further reduced. So this is A, this is B. Now we have reduced it through a single resistance. So what will be the equivalent resistance? It was 12 ohms. So we get here a 12 ohm resistance. 12 ohm, and here it was already a 14 ohm resistance, and here we have a 6 ohm resistance. Now when we do the current distribution again, so what we get, the current through B is passing through this and it is reaching up to A, means the same current is flowing through all these three resistors. This means they are connected in series. So what will be the equivalent resistance? It will be the sum of all the three resistances. So 12 plus 6 plus 14. So 14 plus 6, 20. So it will be, the answer will be 32 ohm.